we had some laws of exponents, laws of exponents, right, where we saw that if we had a to the power r plus s, then it was a to the power r times a to the power s, and so on. All of these rules, plus a few other ones, can be converted into laws of logarithms. So what is going on here? I mean, let's look at what it says up here. It says that the logarithm of a of a product is the same as the logarithm of a of x plus the logarithm of with base a of y. In other words, logarithms convert products into sums. And what does that have to do with this drawing? Well, here you can see if I change my x and my y, it's always such that the height of this plus the height of this equals the height of this, because x and y multiplied together gives you this number. So this is an illustration of this. And it applies to all choices of the base number. Then you can look at what happens if you say x to the power y and take the logarithm. And it turns out that I'll just change my base number a bit. So log a of x to the power y is just y times log with base a of x. In other words, you can pull down the exponent here as a factor in front. And how's that illustrated here? Well, what is this tall thing here? Well, it's 1, right? There's a 2 here, so this is a 1. 1 times log a of x, y. So this is, what is 1 times any number? It's just the number itself. So this is basically, this area is the same as this number on the left, right? What is this? Well, this is the area of this, because this is y and this is log ax. Okay, so what you have on the right here is the area of this. And the claim now is that these two rectangles always have the same area. It's more obvious for some values than others maybe, but it's always true. These two areas always have the same value. Then there's log a of x over y, and it's just the opposite of this. Instead of multiplying, you divide. Instead of adding, you subtract. So let me choose some values here. Maybe it's a smaller a. So what is going on here? Well, here we have some y, here we have some x, and then we find log a of y and log a of x as these two numbers. And then the claim is that you can find this value, so the value of log a at x over y, by just taking this number and subtracting this number. And I hope you can see that this is the case. Right? Yes?
Why does it say log a to the power of 5x?
Oh, that's just because it's a 6, 5, 4. It's just part of the axis. Yeah. It's unfortunate. It's not placed very conveniently. So here's another rule. This is basically a version of that rule here. It's just with roots instead of powers, but a root is a kind of power. It's just power 1 over r. And again, you can see that these two areas are the same. And the area of this figure is, of course, this number, and the area of this figure is, of course, this number.